Utilities are asking for special permission to do basic things like maybe we should upgrade some of our systems from 1950. Now the industrials are tired of it and they're saying, we can actually do this better ourselves. They squandered the opportunity, they got greedy, and they screwed up the grid, and now the same people who gave it to them are done and taking it back.
More than 100 years ago, the electric grid was built by and for large industrial companies. What started with on-site power supply evolved into a network of factories that would later extend to nearby homes. But along the way, the focus, at least for utilities, changed. Expensive upgrades, prolonged timelines, and reliability shortfalls are now fueling a trend of industrials taking back their power. I'm John Engel, Editor-in-Chief of Renewable Energy World. And this week on Factor This, I'm joined by Jereme Kent, CEO of One Energy, a C&I developer and asset owner pouncing on the opportunity to serve the nation's 53,000 largest energy consumers. Kent takes us inside the shifting dynamic between industrials and utilities and One Energy's $300 million push into public markets. That's all next on Factor This from Renewable Energy World. Jereme Kent, thanks for joining the Factor This podcast. It's great to see you.
Nice to see you, John. Thanks for having me.
I was saying before we started recording, and our audience on YouTube, or at least in video format, will appreciate your setup here is quite good. So I think you're tops of the list for guests we've had on the show when it comes to AV. So a tip of the hat to your team.
We like to give good Zoom. So I think that whether or not we want it to be, that's the unfortunate reality of becoming a CEO in the modern day.
Yeah, that's it. That'd be a killer Zoom. That'd be a little intimidating, actually. If I get all of this HD and sound quality coming at me at 9 a.m. for a P&L discussion, it might be too much.
We actually have had people say that our background looked too fake, and so I've had to have somebody walk behind me and be like, no, it really is real. It's just that we finally bought the real camera.
That's great. That's great. Well, this should be a really fun conversation, in part due to the fact that we haven't yet covered the C&I segment from the industrial perspective, which is in the name, but we often think of it more at a smaller scale, small businesses, EV charging, that kind of stuff. And we're seeing more and more industrials turn to on-site clean energy to pick up this slack created by utilities. And looking forward to diving into that more with what you're seeing on the ground and that underlying market shift that may or may not be happening. We'll find out. First, can you share a bit about your background and what interested you initially in clean energy? How'd you wind up here?
Yeah, absolutely. I went to the University of Michigan to study civil engineering. And coming out of that, I was excited to go out and be a concrete guru and a concrete expert. And in the middle of all that process, I somehow managed to accidentally apply to a wind energy company and didn't realize that until the end of the interview. And when the interview was over, I then immediately turned around, asked Jeeves back in the day what the heck a wind turbine was, because I had no idea they were actually a thing when the industry was just getting going again with the new megawatt class turbines. And very quickly realized that these were the coolest, biggest things I had seen, and if they were going to let me play with them, I had to go at least learn more. And fast forward a few years, and I had the chance to go work with some of the largest contractors in the space, and did that for a number of years, building some of the biggest projects in the world at the time. And then ultimately left that to start One Energy 13 plus years ago.
What was that first manufacturer, if you don't mind saying?
Yep, my first job was for D.H. Blattner, and it was a project by Invenergy with a GE wind turbine. So it was called Camp Springs, and it was in middle of nowhere, Texas. So it was in Snyder, Texas. And being a born and raised Los Angeles kid who went to school in Michigan, driving out to the middle of Snyder, Texas was an education in just about every aspect for me.
I bet it was. What's the time frame we're talking about when you first got started? You dated yourself a little bit with the Ask Jeeves reference, but just to be more specific.
Yep, 2006, 2007 time frame is when I really got started and was out in the field.
Okay, so relative early days. You've been along for the ride for a bit now. Explain the vision behind. I refer to it as One Power. I made that mistake. So One Energy, and help us frame the C&I market for industrials. What does that look like?
Well, and John, I think you caught us exposed a little bit because, as you know, we're in the middle of a transaction that'll end up with us as a public company. So today, legally, we are One Energy, and hopefully in the next few months, legally, we are One Power. So I'll stick with One Power as well.
That's a really good podcast tease, too. You're getting the hang of this because we are going to talk about the SPAC a little later on, but go on.
Exactly. You know, the PR team has taught me well as I polish myself up.
It's really easy. It's not as hard as it looks. People give me way too much credit for this stuff.
Your hair still looks better than mine, though, so I'll work on that as well.
Yeah.
You aren't supposed to agree to that, John.
No, I do. And for those listening and not watching, Jereme is bald. I am not. So that is the contrast that you might not have picked up on. But continue with the true nature of this conversation.
Yeah, absolutely. So, One Power is an industrial power company. In our view, we've kind of ignored the C in the C&I, to your point, and we focus on delivering behind-the-meter power solutions to the large industrials. So we're talking about, the large mega factories, several hundred employees, 5, 10, 15, 20, 50 megawatt loads. And what we have found is that's just, kind of a big, burly opportunity with its own, challenges and complexities, but tons of opportunity to help the biggest power users in the country and the world change their profile.
And what does that market look like? Like, how big is that potential customer base? And can you even be more specific on what kind of factories you're typically working with?
Yep, absolutely. So if you pull the EIA statistics, there are roughly 53,000 large industrial facilities in the United States. And that doesn't quite capture everything. There's a lot of unmanned stuff that's pretty big. But of the manned big facilities, there's about 53,000 of them. Those 53,000 facilities represent only 0.6% of the total number of consumers of energy in the U.S., but they consume 26% of the power. So just the sheer scale of the concentration there is huge. And then we work with everybody from, a Whirlpool factory that's making 13,000 plus dishwashers a day to can manufacturers to we're working with Martin Marietta at one of their facilities where they're making a magnesia product, all the way through people who are making Portland cement, through pump stations for Marathon Petroleum, where they're, just have a big 2,500 horsepower motor that sits in the middle of a field to help keep fluid moving through the pipeline. So it's the bigger facilities that tend to be taken for granted, but seem to always have a much bigger power line than you'd expect in feeding them.
Well, and that stat you gave about 53,000 potential customers, but 20% of the power usage in the country is the reason I wanted to talk to you in the first place, because 53,000 might sound like a relatively small market in the grand scheme. You're often hearing companies talking about millions of customers and global scale, all of these different things. But when you can have that big of an impact on a fifth of the supply in this country, then that's a major impact on the decarbonization front. So why are they coming to you in the first place? I mentioned the slack created by utilities, but is there kind of a clear-cut resume for that first intro call that you set up?
So historically, what we're best known for is what we call wind for industry. So that's what we spent most of the last 13 years doing, was figuring out how to build megawatt scale wind turbines for these large industrials behind the meter on site. And so, that pitch typically started with the plant manager, worked its way through an operations and corporate approval chain, and, hopefully resulted in a 20-year fixed rate take or pay contract. What we have found since then is that as these industrials start realizing they can take back control of their power system, that they originally the power grid was built by these same industrials, right? And so they lost control of it, and they're starting to get a taste for control again. And so as they start taking back that control, they realize, well, what else can I do? Can I have more, more wind, so I'm now, more renewable? Could you layer in some solar to help with the summer problem? Could you upgrade my power system because my substation is 50 or 60 or 70 years old in some cases? What else can we do to take back control? And so, the way I always phrase it when I'm at big conferences talking to utilities is, these are the companies that built the modern power grid. They then gave it to you, and you screwed it up, and they want it back. And we see that through all of their desire to have more control, to get as to lower all of their dependence on the risk of utilities, just because it's proven to be a giant risk that they can't control. And when you're running a $3 billion plant and electricity is one of your biggest costs and you have no control over it, that's a tough business. When you realize you can have control, that becomes a whole lot better than your competitors.
You mentioned that industrials built the grid. The grid was designed to serve these large loads and manufacturing centers. What did utilities then not do to maintain that focus and priority? Where did the attention shift to?
Yeah, let's just kind of step back and parse that, John, because we have a little bit of time to talk. So back in the early 1905 to 1920 range, as industrial electrification was first happening, a bunch of big mega facilities, right, everything from like a giant paper mill through the first big cement plants or whatever else, needed electricity to start industrializing their processes. And back then they had to build all of their own stuff. They hired some company that probably had Edison in the name to come on site to build them their own generators to then provide all their own electricity. But then they started to get addicted to it, saying that we can't run our operation without electricity, so we need backup. And what they realized is if those 2 or 3 big industrial facilities that were all 10 miles apart all connected their lines together, all of a sudden they could all have less backup. So they could all have 1/3 of the backup and just all agree to help each other when they needed to. And as that happened, they had to synchronize their generators, and they started creating the grid. And then every house in the middle was somebody who worked for one of the 3. So they started just connecting all of those. And then they came up with this idea that said, what if we centralize power? What if we give this to big utilities who can centralize this and build much bigger, more efficient power stations than we ever could as the industrial? And so that was the whole concept. Utilities could do it better than us, so let's let them do it. They could do it at scale, with more reliability, with more redundancy, more cost effectively. And then they screwed that up. Right? Instead of figuring out how to innovate to bring the cost of power down over time, instead of saying how do we lower our customers' rates year over year, instead of saying how do we get more predictability, instead of saying how do we lock in the price of power for 10 years for our customers, utilities went out and said how do we maximize shareholder value for their shareholders? And they did this with a monopoly, right? So they have these monopolies, but all of a sudden they're able to go out and say I want to maximize my shareholder value, which is not in anywhere, shape, or form aligned with the end user of power. And what you've seen over the last 50 years is that whole competitive advantage that they should have had and should have been able to maintain has eroded. They've lost control. They haven't upgraded their systems. You see stuff like grid mod cases where utilities are asking for special permission to do basic things like maybe we should upgrade some of our systems from 1950.
Yeah.
Right? And so they let it get so bad because they didn't care because they were maximizing shareholder value that now the industrials are tired of it. And they're saying, we can actually do this better ourselves with help from someone like One Power. And so all of a sudden, they can have power on site that is cheaper, that is higher quality, that is safer. They can have, more digital power systems. They can get a text message from their substation when there's a problem. Why on earth isn't the utility doing that already? And so what you're seeing is they had this massive opportunity to be way ahead, and a company like us should never exist. But they squandered the opportunity, they got greedy, and they screwed up the grid, and now the same people who gave it to them are done and taking it back. And they don't want to take it back. They'd much prefer the utilities just did their job, but I'm not holding my breath for that, and neither are they.
Well, and just to play devil's advocate for a quick second, agree on many of the points. I think on the grid mod piece too, which that process plays out over a number of years, involves a number of different players, the regulatory arena as well. We had a regulator on this show very recently talking about the issues of interconnection, and the way that she stated how she approaches the issue of grid mod and utility requests to make investments is regulators are so careful about not allowing utilities to gold plate just to feed that kind of shareholder loop that you mentioned where, oh yeah, we'll build whatever you guys are talking about because then I can rate base that at cost plus. That's great. That's a great business model. But now these utilities, whatever the argument is, have to go to the regulator and prove that the investment is timely and that it needs to be made, that this is the amount of money that should be spent, and here's what the material benefit will be to that customer. And if they can't prove that well, it'll be rejected by their regulator. And that becomes incredibly challenging as we're now in the energy transition and electrification is coming at a rapid pace. And yeah, EVs in the transportation sector, all of these things, we're making these long drawn out projections that can be difficult to prove. So not saying that utilities do everything right, but I think the kind of rules of the game that we've established almost just make it worse. Do you agree with any of that?
I would push back and say, to be devil's advocate back, I think that's exactly the party line that utilities would hope everybody said, and it's all crap. And I will back up that statement when I say that. What we have found is that so I had an interesting experience when we said we're going to go build the first fully digital substation. So I have a 30 megawatt, 138 kV digital substation that powers what we call a megawatt hub, where we're helping big energy intensive industries that are emerging get access to power. And I went to some of the biggest suppliers of equipment in the world, of transformers, of switch gears, of breakers. And I said, what is the top of the line, right? I am your buyer. I am the decider. Give me the best. And they said, well, no one wants that. I said, well, I do. Just help me understand, what condition monitoring is available. And the responses I would get back were, well, no one's buying those. And I went, but you have condition monitoring, right? In every other industry in the world, you have condition monitoring. Can I have condition monitoring on this transformer? And most of the time I was getting feedback to the extent of, we haven't sold a lot of those or any because the utilities don't want it. We haven't, we've never put fiber optics in a transformer to do all of the, protection and control function, because utilities don't want it, because they don't want to have to retrain their people and be different. And so utilities have created a system where they are, so stuck in the mud with their head just buried so far down that, of course, if you're down there looking around, everything looks like mud. The reality is, I built that digital substation for a fraction of the cost of what the utility builds a substation for. My substation is 10 times better than theirs because I know exactly what condition it's in. I get a oil sample every 10 minutes that's analyzed on the transformer and a text message if there's ever a problem. I have breakers that are state-of-the-art from Hitachi that know exactly how far the pistons moved every time when it opens or closes so that I know if I have a problem. And you would think that these would be gobbled up by utilities because it would save a ton of money. And we're talking huge sums of money, right? And if they walked up to their regulator and said, hey, we're going to start building only digital substations because we can do it for a fraction of the cost, get better quality, have better predictability, I haven't met the regulator in the country who wouldn't say, absolutely great. But instead they've created this paradigm of, we have to do it our way, which is literally drawings that in some cases are 50-year-old standards about how wooden poles go in the ground. And so they've created this system where the rules and all the assumptions are all 50 years old and flawed. And then they sit there and say, what else can we do? And I think that's the real problem, is that unless you have regulators who have the technical ability to, raise the BS flag and say, that's just not right. Why aren't you doing this? What are you doing to adopt new technology? Please show me the 10 new technologies you're adopting, right? Please show me why it's still okay to, be worried when a storm comes through. When I have an ice storm coming through, or I have a big, heavy windstorm or even tornado warnings, no one on my system operator team gets nervous that our substation is going to fail, right? You can put 3 feet of water in my substation, it's just fine, right? You can, put 150 mile an hour winds through it, it's just fine, right? Why are we worried the power grid's going to fail? Why is it an okay thing for us to have the conversation? Why does my utility send me a text alert saying strong winds are coming through, not sure if we're going to make it? And why do we think that's okay? Because the reality is every one of those lines should either be protected or underground, and we can stop putting wooden sticks back in the ground. And so I think that's the real challenge. And if you're now all of a sudden to shift back to the industrial concept, now you're the $2 billion plant, you're the flagship plant for your Fortune 500 company, and you have to explain you're down for 8 hours because a squirrel got in the substation, and then the response is the utility puts up a little electric squirrel fence around it and says, see, this is better, right? That's just no longer an acceptable status quo.
Yeah, and
that was my rant. That was my rant, John.
No, I love that. This is already shaking out to be a very good episode. And I appreciate all of those comments, and even my kind of devil's advocate portion of that back and forth, saying that utilities have to play by the rules of the regulators. Well, oftentimes those regulators are either former utility employees or executives, or friendly to the utility audience.
No.
So I should throw that caveat in there and not put on a full on defense here. But let's talk a little bit about a typical project for you. You talked about a digital substation. What are you doing today? And it's fascinating because you almost fill the roles of both developer and utility at the same time for these industrials. You're doing it all. So how do you go through the process of figuring out what is best for each site, and what does it typically look like?
So the way we tend to approach things is, actually, I'll take the time to tell a story because I'm usually so rushed, I don't have time to tell the story. We were helping the economic development arm of Northwest Ohio attract a major public company, and they were very excited this company was going to come in, spend $400 or $500 million on a factory. Create several, thousand jobs, great time. And as part of that, they pull all the key stakeholders in, right? So they pull in all the different utilities, the government officials, everybody else to say, here's how we're going to solve your problems. Here's why you should come to this county. Great. And so for this pitch, and this is, I've got the COO, the CEO, the project lead, the consultant, all for this company. It gets time for the electric utility to talk. And the electric utility says, well, with the power that you're saying you need to build a substation. And so, the company goes, well, can you build us the substation? And they went, oh, no, we don't do that anymore. That's essentially your problem. It's a single customer substation, so you've got to figure it out. You could pay our consulting arm to go probably do it for you. By the way, it's going to be, something like $8 to $10 million, and it's going to take 18 months. And the customer's like, well, what are we supposed to do with this? We don't know how to build substations. We don't want to build. Right. We don't want to build substations, help us out, get power for our factory.
Yeah.
And so then I was speaking next. And essentially the customer goes, so what do you do? And I went, well, I ask you what you want and then I get it for you when it comes to power. And they're like, what do you mean? I was like, ask me for what you want. They're like, can you fix that substation problem? I said, sure, I'll build it, own it, operate it, and you'll never pay, for the whole substation. You just pay me for power as it goes through. And they looked and went, okay, what else? And I was like, you want to be clean? They're like, yeah, we'd love to have wind and solar. I went, great, we'll get you wind and solar. I'm like, well, what do we have to do? Nothing, sign a contract, it's our problem. And they kind of went through their list of, what else they wanted, and we just go, great, that's what we'll get for you. And they go, well, how do you make money? I went, we charge you, more than it costs us to do this, but we're transparent in our pricing, and, our rates are very fair, and they're locked in for 20 years. And so you now have 20 years of predictable power cost. And by the end, you have the customer going, why wouldn't we do this? And so the best thing we can have is that juxtaposition to the utility of, oh, no, we don't do that. And so the utilities have created this void. And we've seen that when you just walk into a customer and essentially say, from a power perspective, what do you want? And we'll get it for you. And our rules are, it has to be behind the meter, which really technically means it has to be kind of the customer's system. We don't go out and build on the utility system. We'll tie into it, but we'll tie into it as a customer. And we don't go inside the walls of a building, right? So we don't want to go in and compete against all the energy as a service companies, right? There are companies like Schneider Electric who would love to come in there and do every individual breaker for you in your building, and they're rock stars at it, right? We don't want to get into that crowded space. The minute you get outside that door and you start talking about 15,000 volts, 35,000 volts, 138,000 volts, the competition sheds like wildfire.
Yeah.
And you're kind of just left with nobody wants to do that. And so we walk in and go, all we do is the stuff between the utility and your walls. What do you want?
We build stuff. That's our bag.
Yeah. Right. We'll build anything that goes from that point to that point. And what do you want and how reliable do you want it? And if you want triple redundant stuff and self-healing power loops around your system, I'll build them. If you realize that it's not worth that premium and you want, something that's good 99.9% of the time, I'll build that for you. And when we build it, we'll have spares available so I can have parts to you in 4 hours. And your substation will text you when there's a problem. And by the way, we'll stop doing all the really dumb stuff that utility operators still do. So I don't know if you've ever had a chance to talk to a plant manager. What pisses them off the most is not the power going out. The power going out is something they can deal with. What pisses them off the most is when the power flickers. So most of the time when the power goes out, you get a boom, pause, boom, it comes back on, pause, boom, it comes back on again. That's called a recloser cycle. And so that's something the utility literally does because they started it, back in the 30s and 40s to try to get the system back online after an event like a tree or an animal touches something. And what they found is instead of waiting to get somebody out there to turn it back on, from to have send a lineman out there, it was good to try 2, 3, 4 times. So they close back in, close back in, close back in, right? And that's how they design their systems now. And the part that's hilarious is that's the single worst thing you can do to a factory. Because what happens is all of these new modern digital factories have a whole bunch of different conveyor belts, lines, and processes, all with different machines, all that respond differently as the power flickers off and on. So some have a little bit of a capacitor in reserve for a few seconds, some keep going, some stop. And so what you see when that off, on, is all the lines get all messed up and all kinds of stuff breaks and all kinds of things that if you had just turned the power off one time would never have broke, right? And the part that's hilarious to me is, we have a circuit right outside my office that has 3 industrial customers on it. They are the only thing on the circuit. There is not a single residential, customer on that circuit, and they still did the same cycle. And so it literally is the thing that is most likely to break those factories and go from a inconvenient power outage to $1 million in damage. And so one of the easiest things we can do is put a switchgear between the utility and that customer that just stops it. If power goes out, we immediately turn off power and don't let it come back on, even if the utility does their thing. And that alone pays for itself the first time there's an issue. And so, these are things that if utilities are walking around to their customers saying, how do we best serve you? Right? Every one of those factories would say, please, for the love of God, don't hit us with a recloser cycle. But instead, we're having to put in our own equipment to do that for them. And so it's just this huge misalignment and mismatch of what the utilities want versus what the industrial customers want that requires people to invest in infrastructure to protect these customers from the grid.
Are those 3 industrials that are your neighbors' customers? Yes.
All 3 are customers,
no?
Absolutely.
Yeah, okay. I figured that we were going to get to that point. Okay, so you gave kind of the broad stroke of what you do. You build whatever they want, but take me through like the specs of an average project for you. Wind, solar, batteries, substation. So are you doing any diesel gen? What does it look like?
We divide what we do into 4 solutions. And let me kind of just talk about each of the 4, and then we'll parse them a little bit. So the first one is what we're best known for. It's wind for industry. The reason we're best known for that is because they're 400 plus feet tall, so it's pretty hard to miss them. And they usually have a company's name on them. So no matter what we say, everybody sees wind turbines first, and we get that. But that is, installing from 1 to 5 or 10 turbines behind the meter on site, projects from as low as 1.5 megawatts, all the way up through things that are 20, 30, 40 megawatts in some cases behind the meter, to directly just provide clean power into that industrial power system. Those are typically how we get to know a new customer. So that typically is the first job we do with the new customer, because we're the only people who really do wind behind the meter.
Yeah, distributed.
We then go into, distributed, right. And I got to be careful because the DOE uses the phrase distributed wind a little bit broader than we do.
Yeah.
So they throw around distributed wind as anything on a distribution grid. For us, it's anything behind the meter. So we kind of clarify it's a subset.
Well, and fewer doing distributed wind. So you almost don't even need to specify, because anyone doing wind at the distribution level is probably having a lot of headaches in making that pencil. But go ahead.
Yeah, you're absolutely right. The next kind of class of projects is what we call managed high voltage. That's where we start just doing all of the not sexy stuff. Right, we install switch gears and breakers and underground cable
when you say
systems.
It like that.
Exactly. I mean, so I'm joking at this point. I just need a shirt that says #NotSexy as I talk about the stuff we do. But that's the reality, right? It's all the stuff that makes that factory go, but that everybody ignores until it breaks, right? And then the next class of projects for us is new. It's what we call net zero projects, and this is where customers have come back to us and said, "Great, we got a taste for it. Take us all the way." And what that means is that we're going in and saying, okay, now we're going to combine every technology at our fingertips to get you as close to zero energy usage from the grid as possible on an annual basis. They aren't disconnected from the grid. We aren't pushing it that far. But we're looking at saying, okay, if you use 40 million kilowatt hours a year, let's figure out how to get you 40 million kilowatt hours a year on site. And so those projects tend to be wind and solar and managed high voltage combined. So a lot of these customers want to try to have that profile look relatively uniform throughout the year. And so to get that summer kind of pickup, we have to bring some solar into this. but those jobs are a typical job might be 15 megawatts of wind, 10 megawatts of solar, and a brand new substation all integrated together. And so, those projects are then taking those factories kind of well above the 3/4 line and hopefully getting as close to 100% as possible. And then finally, that last class of projects for us is what we call megawatt hubs. And that's where what we've done is we aren't producing the power for those sites. We're just acting like the gatekeeper to the grid to get customers access to bigger power than they'd normally be able to get on themselves. So an easy example for that is digital currency mining, right? We all know it's energy intensive, but the average Bitcoin miner doesn't know how to go build a 138 kV substation, let alone interconnect it to the grid and operate it in a cost-effective way on the transmission system. So we started building these sites on spec, so essentially spec power sites, and we designed them so that whatever shows up, we're ready. So that could be Bitcoin mining, that could be a mobile data center to help one of the big companies out there pop up a data center quickly when they need to. It could be anything tied to AI and all the additional computing. But it could also just be a new manufacturer who's going to come in and needs 100 megawatts because they're making cathodes or anodes to go into EVs. And it could also be, which is what we're excited about, charging electric semis. And so we're working with a couple different regional distributors trying to figure out how to charge electric semis at these sites and how to get them to adopt them. But the reason that if you owned a factory or a distribution center tomorrow, right, you can't just go buy 30 electric trucks is there's zero chance you have enough power on your site to plug them in, right? The sheer scale of the load of these trucks is off the charts. Tesla's truck, in theory, if it ever gets there, can charge at a megawatt, right? An entire distribution center, even if it's pretty automated, is 3 or 4 megawatts. Go add 20 trucks, right? And so what they find is they need a site with much bigger power to be able to do that, which is what we're doing with these megawatt hubs and saying, look, if you wanted to charge 20 trucks here tomorrow, we have the power today. Let's do this. And so we're seeing more and more of these emerging industries get desperate for access to power, and we're trying to get ahead of them so that all they have to do is focus on their business.
Yeah, that's super interesting. I love that you brought that up. And a couple of things that jump out to me. You mentioned the net zero on an annual basis, but we also have a lot of our major tech firms that are moving towards 24/7 clean energy and realizing the value of hourly matching and the carbon reduction benefits that come with taking that approach. So the Microsofts and Googles and Amazons that are scaling up these massive data centers, having that holistic solution where you are building the wind and solar on site and then providing these, megawatt hubs where you can give them the power they need. It sounds like that would be just the perfect match.
I'm a big John Oliver fan, right? And so John Oliver loves, is the Last Week Tonight guy. And he does a lot of fun shows kind of addressing obvious problems. And he did a show on carbon credits. I don't know if you had a chance to see it.
I did see that one, and I saw his previous one on the failing grid. Both of them are incredible.
Yeah, he does an outstanding job. And I think the point that he makes about carbon credits very quickly translates to, kind of the whole 24/7 virtual matching thing going on as well, right? So, if you pull in any 7th grader off the street and you tell them that I want to be the cleanest person they've ever met, but I don't want to actually do that myself because I still want to drive a Humvee, fly around in a private plane, light stuff on fire, but I'm going to pay John Engel to go be my clean guy. So, John's being paid by me. He's now riding a bicycle, not using any, disposable dishes and being a perfect
eating the
angel.
bugs.
Exactly. At the end of the day, that 7th grader looks at you in the eye and just laughs at you when you tell him, see, now I'm clean. Right? And that's exactly what this 24/7 matching stuff is. And I'm not saying it's not, a good step in the right direction. It's better than nothing. But the reality is it's not actually making the end users clean. And so when you talk about the megawatt hubs and you talk about net zero projects, we're talking about taking billion-dollar facilities that are some of the dirtiest facilities in the world by every measure out there because of what they do and make, and turning them into some of the cleanest. On-site, draw a circle around the plant and know it's cleaner. And I think as you see more and more people wrap their head around what decarbonization is, what it means to be green, what it really means to be environmentally friendly, there's going to be a lot less, paying the stranger 500 miles away to be clean, and a lot more saying, how do I actually get clean? How do I actually build the plant of the future? How do I actually, take a operation that for 100 years hasn't cleaned itself up and clean itself up for the next 100 years? And we're tremendously excited about that because that really moves the needle, and it moves the needle for the community that plants in.
And just to distill your point a little bit, from what I gather, is you're more criticizing the virtual power purchase agreement structure, where you're generating an electron out in Oklahoma at a wind farm and counting that as an equal electron for your factory in Louisiana, where the grid is dirty, and saying that you're right. But with 24/7, I mean, it is a little bit more nuanced that some of these firms, Google and Microsoft specifically, are trying to do hourly, locational, additionality, all of that kind of stuff. So I think that kind of tips the scales, at least in my view.
I agree with you. It's a step in the right direction. I will say that what I find interesting is that the people who are actually putting a price on carbon, right? There's very few kind of places in the U.S. where there's actually a price on carbon. One of those is in the low carbon fuel standard that California put out. And what they've said is if you're going to produce renewable clean fuels that come into California, and you're not in California when you do it, all that we're going to count is renewables that are physically delivered to your site for clean energy. And so I find that very interesting, right? So if you want to produce renewable diesel and deliver it to California and making up a facility, if you have a magic facility that now sits in Illinois, you can't buy renewables from any place else. They have to be physically on site delivering power to you behind the meter in order for you to count them for California. And so I think the problem is the difference between a virtual PPA and kind of the 24/7 matching with additionality that isn't actually delivered gets tougher and tougher to see and grayer and grayer. I'm not saying it's not a step in the right direction. I'm not saying it's way better than just buying power off the grid. But I think that none of those are anywhere near as real as saying, this power is actually making this facility cleaner. The rest is just saying you're going to be a good neighbor on the left side while you maybe aren't the best neighbor on the right side. And we can debate how good the left and the right are together.
Yeah, and you're right. And a number of studies have pointed out that just straight up annual matching is not going to do the job. For offsite, far-flung projects is not leading to significant decarbonization. It may be displacing other resources. It may be making an impact there locally, but for wherever you're operating or your business is positioned, if you're not delivering that power even somewhat regionally, then you're not making the impact that you're telling everyone you are. Exactly. So let's move on a little bit here. I do want to learn a little bit more about the business model and how the economics work on your end. You mentioned that you operate these assets. You go into long-term contracts with the customer. How does that compare with the costs that they incur from the utility? Are they saving money? Is it as easy to calculate like that?
Yeah. So, at the end of the day, all of our projects where we finance them get financed based on the fact that we're going to charge a fixed rate per kilowatt hour of power. So when we sign a contract, our customer knows here is the price of power by year. In most cases, it's the same number every year. So it's literally locked in for 20 years flat with no inflator. In some cases, a customer says, hey, I want the first 5 years to be a little bit cheaper. And then, years 6 through 20 are flat. We'll let them shape that curve. But we price that back into the same return and the same debt coverages for us overall. And so most of our customers make the financial decision first. Now, I will say that when you're talking about 20-year fixed rates, the financial decision tends to be meet or beat my current rate, because if you can even just meet my current rate and you can lock it in for 20 years, that's a huge risk mitigation tool as well. And so, if you're a big energy user, you're looking at both the risk of the power grid, going up in rates like it did 2 years ago, and seeing a huge spike and how to mitigate that risk. And then on top of that, you go, hey, if you can meet my current rate and all of a sudden you're completely clean and you're fixed for 20 years, that's, two really big pluses in the column. Now, we prefer to be a little bit cheaper than the grid, and we tend to find that when we're about 5 to 10% cheaper, which we are in a lot of cases, we end up, getting that job to move faster. But more and more, we're seeing customers who see the risk side of this, right? If you had pulled in every gas analyst you knew 5 years ago and said, will we ever see $10 gas again? They would have all just laughed at you, right? And they were advising all of their corporate clients that's never going to happen. And we all, in the last 24 months saw $9.90 gas, at Henry Hub as we, with Ukraine. And the end result is every big corporate risk person is realizing they don't even have a handle on the risk, right? The impossible just happened and everybody's going, oh, but it won't happen again, right? And so, what risk people don't like at big companies is when the upper end, their worst case risk line, wasn't actually the upper end. And so we're seeing a huge shift towards companies who want risk mitigation in addition to day one value. Does that make sense?
Yeah. And I want to expand a little bit on the natural gas price volatility too. So you mentioned 24 months. So the last 2 years, was that a real flashpoint for the company that you saw a surge in interest? Has it kind of maintained over the last 10 years? But I imagine that had to be a pretty big factor for the industrials.
Yeah. I mean, our best salesperson is the alternative, right? And that's what makes companies hungry to find a solution. And so, the companies who had been living in the glory days of $3 gas, who got caught and exposed, absolutely said, we can never let this happen again. What levers can we pull? And if you start looking around at what levers can you pull, there aren't a lot of levers. And there aren't a lot of levers that are 20-year solutions. And so what we've seen is a push from a lot of our bigger customers who had a lot of exposure to say, how do we take a real serious risk mitigation step? And by the way, how do we get ahead of kind of everything we know is coming down the pipeline on carbon? But today we also just have to lock in a bunch of rates to have some comfort.
This is backtracking a bit, but before we kind of round out the utility piece of this conversation, I do want to ask you something about supply chain. So given that you are developing these projects both on the clean energy side and the poles and wires, at least on-site infrastructure to get to the grid, are you experiencing the same extended lead times that we're hearing about from utilities, that they can't get transformers, substations, relays, whatever it is? It seems like it's, years at this point. And that's been an explanation at many times for why we're not making it better.
Yes and no. We are not like a utility in that we are allowed to make reasonable decisions. So in some cases, we've been able to just find non-American, highly qualified suppliers, right? Mm-hmm. So in some cases, I've been able to get UL accredited pad mount transformers still in months, not years. They just aren't made in America. And, that's because if we try to call up places that are making them in America, it's 2, 3, 4 years to get one. What the world is really seeing is that, we had been in a several decade globalization era, and we all got a little bit lax about how international our supply chains were and what would happen if we screwed up. And the biggest lesson learned for everybody should be that, when the Ukraine invasion happened, the world suddenly realized about 25% of the grain-oriented, special steel that goes into transformers was made in Russia. And you take a supply chain that was already stressed, where it was already okay to have a 1-2 year lead time, and you take 25% of their raw materials and throw them out and say you can't get to those now, the world gets very complicated very quickly. And so, the part that I find interesting is that the fact that it was okay to have an 18-month lead time before, right, for some of these big transformers is part of the problem, right? In almost any other industry, that would not have been okay. But utilities didn't push their global suppliers to say, build more factories, or I'm going to build my own or find somebody else, right? You're seeing it with batteries, right? Give me what I want, or I'm going to go build my own gigafactory somewhere and build all my own stuff. That didn't happen in the utility space. They let their suppliers get lazy, and they let their suppliers have terms that would never have been okay in any other industry. And then when you take that and you take 25% of the supply away, you're now seeing the compounding catastrophe that is the electric supply industry. And I harass my suppliers for this, right? Why isn't every big manufacturer in this space building new factories right now in the US? Right? Instead, they're raising their rates, saying 2 or 3 year lead times are fine, and kind of putting their feet up, realizing they're going to make a bunch of money. The reality is somebody needs to come in and disrupt it. It is not that hard to build a big transformer, right? That, there are definitely skills that go into it. There's definitely big processes that have to do, but, somebody could very easily stand up a new transformer manufacturer a whole lot easier than a, new semiconductor chip factory. Right. And we could solve this problem in 2 years in America if we wanted to, and have it never happen to us again. The utilities aren't making that happen. And again, that's the kind of stuff that would only happen with your head, buried in the mud a foot like it is right now.
So let's go back to the SPAC tease that you made at the start of this conversation. Big change in the works for you guys at One Power, or soon to be One Power, a $300 million SPAC deal that'll have you listed on the New York Stock Exchange. Why did that make sense for the company in this moment? And where are we in that transaction life cycle?
Yep. So we have announced that we have entered into a business combination agreement with Tortoise Ecofin Acquisition Corp. 3. They trade under the ticker TRTL on the New York Stock Exchange. The end result of that is that we will end up as the public company One Power and trade under the ticker 1P, also on the NYSE. That transaction was done because we need a bigger boat and we need more capital. And the candid reality of being the size we are in the energy and power space is that there really is no good growth alternative for us in this industry. The power industry has historically been an M&A industry or an infra fund industry. So when you get to our size, you either get swallowed up by somebody or you get, private equity that puts you into an infrastructure fund ultimately that then, either owns you and you remain PE owned for the rest of your life and you have great access to capital, but you kind of have all your ownership taken away, or you just immediately get rolled into some synergistic something that somebody else came up with. What we found talking to over 400 different power investors over, kind of a 3 or 4 year period is that there really isn't true growth equity money like there is in other spaces. If we were a software company, you would just call this our Series D or Series D or Series C or Series D round, and it'd be a non-controlling round, and it'd be a round structured at, growing your commercialization now that you're out and you're headed on a path towards, being EBITDA positive, and you'd have 10 tickets lined up with term sheets to give you that capital, and it's all very well defined what that would be. The minute you're talking about power assets and kind of the more capital intensive nature, those investors just don't exist. So you can get bought by a utility, bought by, some other big fund, merged into something, and none of those sounded fun to us. So I want to stay in control of this. And the irony is that by going public, we're in a far better position for me to stay in control and for, my current board of directors to stay in control. And, it's pretty hard for us to swallow the idea that, getting bought by a utility would be helpful to the business model, considering our entire business proposition is to end their business model. So, we couldn't figure out how to stay in control and grow this company as fast as it should grow. The other alternative was grow it much slower. And the problem is there's so many challenges now that I don't want to take 5 or 10 years to get to scale. We have customers calling us that we're saying no to right now because we don't have the capacity. And the only way you solve that's with a bigger boat. And if that means I have to go public and, learn to cuss less on Zoom calls and smile a little bit more and have earnings calls, then I guess that's what I have to do.
That's why we're doing this interview now and not in 3 months, because I have the publicly traded guys on the show all the time, and they really have to button it up and no forward-looking statements, all that crap. Kind of give me the scoop. What are we talking about here?
Yeah, I mean that's the challenge is you have to think a lot more about what you say. But I will also say a lot of those. I'm under the same kind of button that they are right now since we've announced the combination agreement. I still think that a lot of guys just don't like to answer a lot of questions, and my hope, sure golly gee, is that the public will appreciate somebody who actually isn't full of it and will answer questions and will have the tough conversations, because the reality is one sentence phrases aren't going to solve the power grid problem. You need somebody mean enough and crusty enough and a team mean enough and crusty enough to go out and take on utilities and their 100 years of crap, and to go actually help, do all this not sexy stuff to fix the grid.
Well, and I'm probably going to splice in your interview with one I did with Sunnova CEO John Berger, just because between the two of you, you could just have an ongoing multi-hour tennis match over your distaste for utilities. I think that would be a pretty inspiring mashup. Yeah. So what's the timeline look like? Next few months? Are you able to even say? Because I know you announced in August.
Now
so
you're back
curious.
to this forward-looking statement stuff, John. No,
I have to try.
We are working very hard to get all the paperwork filed with the SEC that has to be filed. We have to file the S4. Once the S4 is filed, then you start somewhere between a 60 and 120 day process, depending on the SEC's mood, which I think is great. And I love the SEC, and go all SEC people who are watching me.
You said you weren't full of crap.
Yeah, exactly. Except for the SEC, John. We all have to be nice to the SEC.
Yeah.
But the end result of this whole thing is that, in months, not years, we should, effectively have a approved S4 from the SEC, and then we go through the process for a merger vote, and we get to make our case to shareholders to not redeem and let us keep as much of that $300 million and then some as possible.
When we last talked, probably a month or so ago, you told me that most companies crumble when they get to your size and in this position in kind of the life cycle. What did you mean by that?
Well, I guess there's two things, right? So one, it's very easy just to get swallowed and lose control, and somebody else takes over. And excuse me, that's kind of, it's easier to have somebody buy your boat than try to build a bigger boat at this size. The other thing that happens is that you're seeing a lot of companies try to use the SPAC market who shouldn't be using the SPAC market.
Oh, you don't say.
Right. I don't know if you've noticed that flying cars aren't working out all that well.
Yeah.
And so you're seeing these companies that, SPAC'd and are now trading at $1, $2, $3. The reality is there's no way to be half in this case. You have to be all in. And so you have to be ready to, do quarterly earnings calls and have FP&A and do projections and run an IR team and have all the other things in house to be a public company. And if you aren't ready to do that, that money is only going to, make it easier to sink your boat. And so the reality is you have to be ready to take on all of those burdens and not crumble. And that's hard. It's not supposed to be easy to be a public company. But if you do that right, then, you get to live and die by the stock market and by the case you make to your investors and how you actually increase shareholder value. And, we think that we've taken all the right steps to be there. We think that we've created the right structural alignments in the deal. We've done some stuff to make it very clear that we can't make a quick buck. I personally cannot make a quick buck on this process. We're in it for the long haul. I've been doing this for more than 13 years, and I plan on doing it for well past the next 13 years. And we have to make that case to the market. And if we screw that up, the market will do what it does, and it'll make us crumble.
Frame for me, the typical workload that you guys take on. You mentioned saying no to some potential customers, which just in knowing you for almost an hour now, I can imagine drives you crazy. But these are multi-million-dollar projects, individual projects. Some, I'm assuming, tens of millions of dollars as you're getting up into the multi-gigawatt. Kind of the general rule of thumb, at least in solar, has been like 1 million a megawatt, I believe. So I don't know what that is in wind. And probably much more.
2 million a megawatt in wind, 1 million a megawatt in solar is a really good starting point.
Okay, so that ties up a lot of cash, and I imagine that you are frequently tapping your debt facility. But how many projects can you have ongoing at a given time, and what changes once you go public? Are you able to take on more? What
we have stated publicly, which is probably a fair answer to this, is that we have more work in the next 18 months than we've had in the last 13 years.
Wow.
And so, and that is me pushing my team to extend our capabilities and to be more efficient about things to deliver on that. We can't take on more than that until we know we have a bigger boat. One of the things that we've done, for better or worse, and it's kind of one of the controversial business positions we've taken, is that we've said we aren't just going to do what a lot of developers do and just say yes and then figure out how to pay for it later. We will not take on a job unless we know we can deliver that job, and that means we have the resources and the capital to do it. And so we're at a point where we've pushed our current boat as far as it can, and until we know we have that bigger boat, we won't commit to more. Excuse me. What we have found is big industrial customers, as much as they don't like that in the moment, tend to appreciate that in the long run, because they know that if we say we're going to do a job, we are going to do a job, period. Right? And so that discipline is not traditional, right? I'm sure you've had a bunch of people on who've talked about their big pipelines. I always love the stat that if you added up every pipeline available, it's like 10 times the power the United States needs.
Yeah.
Right. So we don't like to talk about pipelines. We like to talk about, things we're actually doing, which has made it a challenge, right? Because the first question I get asked by analysts is, what's your backlog? What's your pipeline? And the answer is we've signed all we can sign. And if we had capacity to sign more, we'd sign more. And that's a very weird response for them, and their usual next response is, yeah, but what's your backlog? What's your pipeline? And you're like, again, you're missing it, right? We've sold out of everything we can do for the near term, and I don't want to sign a project saying I plan on getting to it in 2 or 3 years. So we'll see how that position evolves, but that position has worked very well for us in the past. It's why we have the kind of relationship we do with world-class customers, and the trust that we've earned over the years that goes so far that they'll let us literally own their substations.
Yeah, multi-gigawatt pipelines are a dime a dozen these days. Everyone has at least a gigawatt in their pipe, and you
Exactly.
never know how much of that is mush. You don't know how much of that is just a land option or early stage development. It doesn't seem to matter. It's more about telling this story to that future PE shop that comes in and swoops up the pipeline and gives them a nice, few million bucks on the top when they do the transaction. Like, we know how this works. It's still a business, and people are trying to take that exit path. It's financially prudent for them.
That's exactly it. And candidly, there's so much pressure from those PE firms and from the bankers and everybody else to just layer in your pipeline. Oh, look, you looked at a job and waved to a landowner that's part of your pipeline. We talk about just signed contracts. So one of the things we're doing, again, maybe this makes us completely crazy, but we're trying to cut through all of that crap with the public and with analysts and say, okay, if I refuse to talk about pipeline because I think it's all, crap, instead what I'm going to do is I'm going to publish 2 metrics. One is my 20-year contracted revenue, and one is my 20-year contracted operating profit. And so we're actually going to publish those metrics. We did it in our announcement, and we're going to continue to do that, to say, here is what's actually signed through binding contracts that's operating or we're building and will be operating. And now all of a sudden you can compare us. Because if you went and took that developer with 3 gigawatts in their pipeline, it's like 3 guys in t-shirts and a laptop as a company.
Wait a second.
What is your contracted 20-year revenue? Yeah, exactly.
That seems like a bit of a shot across the bow.
Their response, looks a lot more like 0 and a lot less like, 700-800 million. And so, in our view, those are the only metrics that are real. But the problem with being the first person to report a metric is you have to kind of get everybody else to buy into it. And so our goal is to put that metric out and start challenging others to do that. But you have to find some way to parse who's got real stuff and who's got, a magic pipeline that's, that's definitely not something you want to bet on.
Jereme Kent, this was a lot of fun. I appreciate you for having a very candid conversation. I think the audience will appreciate it as well. Thanks for coming on the podcast.
John, thank you for your time. Appreciate you chatting with me today, and look forward to talking more later on.
Thanks again to Jereme Kent for joining the podcast. Factor This is a production of Clarion Energy and Renewable Energy World. Join us every Monday as we take on solar's biggest stories with industry leaders who actually move the needle. And please leave us a rating and review wherever you get your podcasts. Thanks for listening, and we'll see you next time on Factor This from Renewable Energy World.